All right, I guess we can get started. Thank you all for coming today. I just want to thank the organizers of NDC Oslo for having me speak. Also, before we get started, for those of you in the back, I'm so sorry. Some of the code samples might be a little small. Try to make them as big as possible in order to be viewable on the screens, but we'll do our best. Anyway, I am Simon. Oh, that didn't work at all. Let me try that. Yes. I'm Simon MacDonald. I work for a very small internet startup called Begin. Yes, B-E-G-I-N. It's a 5-letter domain. I don't know how we got it. Every week we get emails asking for people to buy it off of us. Often I get to respond with, that's not even the best offer we've gotten this week, so that's always fun. But anyway, what we do at Begin is we make it easier to deal with AWS. If you've ever logged into the AWS console, there's like 160 choices that you have to start making right away, and that's very daunting. So we give you a reasonable set of defaults to get going. Anyway, I needed to say those couple of sentences just to justify my trip over here to Oslo, so thank you for listening to all of that garbage. Anyway, if you need to get a hold of me after the conference or at any time, probably the best way to do it is on Mastodon. I used to have Twitter on that slide. You could actually use @MacDonaldST at Twitter, but that is a giant tire fire right now, and I'm trying to do as much as possible to stay away from it. But anyway, the Fediverse is very interesting. I'm quite enjoying that. So yeah. Before I get started with the meat of the talk, I just want to preface the fact that I really love JavaScript. Even though there is a sticker on the front of my laptop here that says the anti-JavaScript Club, I do love JavaScript. I don't want you to get the impression that I do not like it at all. I write it every day. I mean, everybody kind of loves JavaScript. The thing is, some of us just love JavaScript a little too much. Has anybody else ever encountered any situation like this where you have? Oh yeah, okay. Somebody actually put up their hand. Thank you, I appreciate that. But yeah, how many websites have you gone to where you're like, oh, it's just a simple HTML form that has 4.7 megabytes of JavaScript? Why? Why do we do this? Let's just stop doing that. Can we all agree? Okay, maybe you'll agree after the talk. But yeah, let's try to stop doing that because that is just pretty insane. All right, so the talk itself is adventures in rendering off the main thread, and I think the first thing that we need to do is talk about why we care about the main thread, because a lot of stuff happens on the main thread of your browser, and let's kind of dig into some of the responsibilities that it has. All right, so on the main thread, its responsibilities are, first and foremost, it parses the HTML. So your browser requests a page, the HTML gets downloaded, and it gets parsed by your browser. That's happening in the main thread. It's going to build out the DOM. It's going to take all of that parsed HTML, build all the DOM nodes for you, and then it will request CSS. So again, the cascading way that the browser works, HTML first, CSS second. Then it'll parse out all the CSS in order to apply the styles to your DOM. And then finally, it downloads the JavaScript, parses it, executes it. So the JavaScript is always the last thing that happens in that page. So think about that. And then, of course, after everything is all loaded, the main thread is responsible for responding to any user threads. So button clicks, wow. I thought I was recovered from the trip over, but maybe I'm not. Anyway, button clicks, if you tap an anchor, all of these things are handled by the main thread. Now, the problem is, any JavaScript that you run on the main thread that takes a long time, and basically Google defines a long time task is anything over 50 milliseconds. Anything that takes over 50 milliseconds, they do not like at all, and they will penalize your website. Anything over 100 milliseconds is really going to damage how well your page acts for your users, because it'll be a very noticeable thing. Lots of folks have done experiments on human-computer interaction, and they see that anything over 100 millisecond delay is where people really start to notice things happening. So whenever possible, try to take those long-running tasks and chunk them down to something under 50 milliseconds. But we can actually do a little bit better than that. And especially for these two very important numbers. The first is the 60 frames per second, and that's the rate in which animations on your web page will appear smooth. So you really need to be doing the repaint of the web page 60 times every second. So that only gives you 16.7 milliseconds to do each frame. Now, the thing about that is the browser is going to take 6 milliseconds itself just in order to do some of the tasks that it needs to do. So you really have 10 milliseconds to execute everything. So if you are using a ton of JavaScript, you're going to have these pages that are janky. Is that a term that people are familiar with? Yeah, anyway. Jank is basically when the animations just become blocky and you can really notice that they're not super smooth. So any kind of slow JavaScript tasks that are happening or very expensive CSS properties can result in this kind of jankiness in your browser, and you won't get the smooth animations. Now, let's go to the state-of-the-art in web application development. It's like, oh, no, sorry, that was actually a joke. I just love to crap on Meta all the time. For some reason, they were hit with a 1.2 billion euro fine, and their stock went up. So I don't know what to tell you. Especially in North America, the stock market just seems to be a game that people play instead of anything rational. Anybody else see that? Okay. We're all going to cross our fingers that that doesn't happen again. We had a little bit of a problem with TechCheck, but we're getting there. Anyway, actually, let's go to the actual state-of-the-art in web browsing or web frameworks. Okay. If we take a look at a typical index HTML for many modern frameworks, it looks something like this. We have a div, which is basically the insertion point. This is where the framework does the client-side rendering and attaches all of your nodes into the page itself, and that's great. And then we have a script tag, which goes ahead and loads all of the client-side rendering code that is going to generate the HTML for you and put it into that div. So, all right, that's not too bad. It's a very clean HTML. You only have, 10 lines in there? Well, 11 really. But ask yourself the question, what happens if JavaScript fails? Yeah, you're kind of out of luck. So if you're doing any kind of client-side rendering at that point in time, you're relying on everything to be done through JavaScript, you get nothing on your web page whatsoever. Now you're asking yourself, yeah, that never happens, does it? I have an example. It almost never happens, but it does. Oh, wait, I need to, bear with me. Wow, okay, I don't want, yes, exit full screen mode. All right, this is Canadian Tire. Yeah, it's not just a store that sells tires. I know it's a really dumb name, but it's like it started as a garage like 150 years ago and kind of built up from there. Well, maybe not 150 years ago, but for a long time. Anyway, Canadian Tire is a national store chain in Canada, and this is their website. It looks great, doesn't it? But if we turn JavaScript off, that's what we get. This very big retailer in Canada, if anything goes wrong with JavaScript on the page, it's dead. So you can't buy your tires or whatever else you plan on buying that day. And actually, I've debugged it a little bit. It ends up being an Akamai pixel that is loaded on the page. And if that pixel never loads, then nothing else on the page loads. And that's wild. Don't ever do that to your users. That's just, oh God, what's going on? Ooh, okay. All right, maybe don't ever change stuff ever again. Gotcha. All right. So yeah, what I was saying is that yeah, JavaScript never fails, right? And it's like, well, we just saw with that Canadian Tire example, if I specifically turn off JavaScript, the entire site breaks, which is terrible if you actually want to buy something. In fact, I have a specific browser on my computer that I use to buy stuff on Canadian Tire. It's there's a Firefox profile I have, and it's the only thing that'll actually work with that properly. Now, how often does JavaScript actually fail? Most of the studies I've seen over the past 10 years say that the failure rate is somewhere between 1% to 2%. And I've even seen a recent one that says up to 3% of all visitors to your site have some sort of JavaScript problem. Now, I'm sure that for some of you, that seems like a really low number, and others probably think it's a really high number. But just imagine 3% of all of the page loads, not just visitors, but all of page loads can have a problem with JavaScript. And there can be many, many reasons for that. So different failure reasons for JavaScript could be very simply a network problem. The HTTP request for the JavaScript failed itself. Also, there could be some sort of corporate firewall that is blocking the JavaScript. Now, that's never fun. Whoa. There could be something interfering with the JavaScript. If you've ever been in an airport, you know, like some of the portals that they have in the airport that causes lots of problems with loading of web pages. Also, one of my least favorite things that I recently run into is that I have bought Eero devices in order to put a mesh network for the Wi-Fi in my house. Eero has this amazing ability to cache stuff, which is a terrible thing when you're a developer and you're having to reload stuff from staging and you're like, why isn't this working? And you spend so much time trying to debug it and you find out that, oh, no, it's the damn router. So that's never fun. As well, has the user switched off JavaScript? So you saw an example where I just went in and hit the button that turns off JavaScript. You know, some people do that on the web. They don't want to have all of this JavaScript loaded because, I don't know, there's a lot of tracking that goes on. I used to work for Adobe. The amount of information that Adobe collects on you as you go through the web is insane. And at the same time, Facebook is doing it, and Google is doing it, and everybody is doing it. And so, yeah, sometimes you might want to turn off JavaScript just to be, I don't know, slightly anonymous or feel like you're just not feeding that machine. Is data saver mode turned on? I have a teenager. What they tend to do is when they're running low on their data, well, maybe that's not an issue that you have in Norway. Quick thing about Canada. We have terrible cell phone companies. I mean, everywhere has terrible cell phone companies, but ours are really terrible because there's three, and they all collude with each other to have extremely high prices and low data caps. So what teenagers do in Canada is they will turn on data saver mode, and one of the first things that does is doesn't download JavaScript from the web pages that you go to, so you get all sorts of issues that way. And then, of course, is there a browser plugin that is messing with the JavaScript? I mean, there are lots of ones that kind of munge with your JavaScript a bit. And in fact, ad block, if you're running that, which I do because, my God, there's so many ads on the web. But running ad block, it will block certain ads. And sometimes badly written websites will depend on the ad loading in order for the rest of the page to actually work, which is basically what was happening with Canadian Tire, which is insane. Oh, yeah, sorry, the ad blocker was what I was going to be talking about. And then, of course, you could have an older browser. If you have an older browser that doesn't support some of the modern JavaScript features and you haven't transpiled in order to be able to serve these older browsers, you can run into issues. There was a kind of a famous issue in North America where an older lady just wanted to book her COVID vaccine, and she couldn't because her browser was so old. She had an old desktop computer, and it didn't support modern JavaScript syntax, and the website that the government put up did not support it. So there was a fight there. As well, I don't know, I have visited my in-laws, and he's like, hey, can you get my computer running downstairs? And I boot it up, and it's Windows 95, and I'm like, I could, but I really shouldn't. This thing isn't safe on the internet. So there are older devices that are out there, and we need to be cognizant of that. All right. So those are all different reasons why JavaScript may fail. And when you take a look at the failure rates, again, it's not that much when you only have a few users or few visitors, but as you go up and up and your site becomes more popular, this relatively rare occurrence becomes more and more regular. And that leads to something that looks like this. Or just even a blank white screen. You just get those terrible loading spinners. All right, so that should worry you because JavaScript errors are basically costing you money, either directly because of lost sales, because people can't complete their shopping experience, or due to lower SEO scores, or they just can't use your app because things go completely wrong. And that's where we get into our first adventure in rendering off the main thread. So the best way that I know to avoid JavaScript failures is to reduce the JavaScript bundle size and stay within our performance budget. So that allows us to eschew client-side rendering and stick with server-side rendering instead, which is a technique that I prefer to use. So a quick overview of server-side rendering. So the way the browser works is it requests a page and our server responds with accessible HTML. Then the browser is going to render our HTML, and at this point, not only is your page viewable, but it's also interactive if you've written it with progressive enhancement in mind. Because you can do a lot with modern HTML without ever adding in any additional JavaScript. So that is what I recommend for folks. And then, of course, the browser requests our JavaScript, but even at that point, if something fails, it doesn't matter because we have working HTML from the previous example. We can still, buy that toaster. And then finally, the JavaScript is parsed, and we are adding more advanced functionality to our page. We're kind of adding that little pizzazz to the page to make things like even better for our users, but they can still get their job done without having to have JavaScript load. All right. So some benefits of server-side rendering. The time to first interaction is much faster. Because you have all of the HTML loading and you're able to start acting on the page immediately once the HTML is loaded, your time to first interaction is faster. That's great. The search engines can better and more easily crawl your site. They don't have to wait for JavaScript to load, and in fact, some search engines kind of decide, like, hey, we're not even going to bother to load your JavaScript, and that can penalize you. And then it works on older devices, so it doesn't really matter how old the device is. Pretty much everything works with HTML. HTML is a wonderful language that there's no breakages. It's really only forward compatible with HTML. So if you've written a site in, 1995 when you're in university, you can actually take that and view it in today's browsers with zero changes whatsoever. They'll just have that work for you. I don't know of too many other programming languages or runtimes that allows that to happen. All right. You may be thinking, wait a second, isn't server-side rendering slow? Okay, no, it is not slow. While it may be a little bit slower to time to first byte, because you have to render the HTML on the server and then send it down, whereas a client-side rendered solution, you're going to have that small HTML stub that you send down immediately. So we're kind of trading which performance metrics we want. But once you have that HTML loaded down, things will perform better. So your modern front-end web apps, where you're using cloud functions to deliver HTML, and they're backed by modern cloud databases. The databases these days are amazing. So we use DynamoDB a lot in work, and this isn't an ad for DynamoDB, but the fact that I can request data from that database and get it all back in under 10 milliseconds is insane. I remember the days of writing database connection pools in order to have to get away from how slow the old SQL databases were. So if you're using a more modern database, you can get insane times from them. So having all that together, it's like more than fast enough to complete with client-side rendered applications. All right. So our first lesson in rendering off the main thread is is to leverage the server to do the initial render. So anytime possible, try to use server-side rendering with like pure HTML that is accessible to your clients first, and then you'll be much better off. All right, so we're getting back to tech problems. Anyway, that's fine. So in our second adventure, we'll look at building our app with reusable web components. Now, question that you might have is, can I still use a component framework when I'm using server-side rendering? And the answer is yes, of course you can. Many frameworks like Next and Nux provide the ability to build components with React and Vue, etc. But here's where I have to ask you a question. All right, how many people in the audience have used jQuery? And if you don't mind, just throw your hand up, that's great. Yeah, all right, so if you look around, almost everybody has used jQuery. How many people, when starting a project today, would include jQuery in it? Yes, there's always at least one brave person who will admit to it. I respect you, sir. Thank you so much. So you might have noticed the first question, almost everybody in this room put up their hand. And the second question, only 2 people were brave enough to admit it, which is great. So why is that? Well, a couple of reasons. First, jQuery initially came along because we had the browser wars. We had Internet Explorer, Firefox, Chrome, et cetera, et cetera, et cetera. They all decided to implement things completely differently, so we needed this shim over top of things in order to smooth out all those differences. And jQuery did that, and it was amazing, and I loved it, and we all used it. However, as time went on, a lot of those things went away. because our browser vendors have decided that working together and building to standards is much better than trying to add something called JScript, which is what IE did back in the day in order to kind of get people only to use their browser, which was insane. But yeah, the browsers now collaborate with each other and do the HTML standards, and as well, they're evergreen. So you might see that update thing in your Chrome or your Firefox all the time. So it's like constantly updating in the background to make sure that things are mostly up to date. Now the other thing that jQuery was amazing at was its ability to select elements from the DOM. And then what happened? We don't use it anymore because we have like the document.querySelector family of JavaScript APIs now. So that makes it much easier for us to just say, okay, we're not going to take those 282 bytes of jQuery, and we're just going to use document query selector all. And I don't know, how many of you folks actually just have, var or const $ equals document.querySelector all? I mean, there you go. That's most of what we used to use jQuery for. So the question is, why do we use large JavaScript frameworks like React and Vue? We have another thing that we can use instead of opting into these giant JavaScript frameworks that's already provided by the platform, and those are web components. So why do we use these giant frameworks when web components exist? So, quick overview of web components. We have mainly web components are 3 different specs, and the 3 specs are the custom elements ones. This allows you to define a new custom element so that anytime your browser encounters a tag with this name, we say, hey, load this JavaScript file in order to give you the behavior of that tag. The nice thing about that is if the browser encounters a tag that it doesn't know what to do with, it just treats it as a span. So it's backwards compatible. So even if you have super old browser that doesn't know what a web component is, it's okay, it'll still work. And then of course, we have the shadow DOM. So the shadow DOM allows us to encapsulate all our styles into the web component itself. So that'll keep your styles of the web component from bleeding out into the rest of your application, which is really handy when you are building web components that are going to be used on a third-party site as well. So that way your button styling will not impact their button styling, for instance. And then, of course, we have the slots and template specification. And that provides us a way for us to compose our custom elements out of other custom elements. So you can build up some very advanced functionality from a bunch of leaf nodes. And then, of course, the template itself allows you to reuse that custom element multiple times on the page in a very performant way because it's just you're cloning the template each time. The template element is really cool because it's like one of the few things that you can actually put in an HTML page that does not visually show up in any way unless it is used by the web component. All right, so here's where we get into some source code, and hopefully folks in the back can sort of see it. I try to make it as big as possible. This is where we're defining our first web component. Anyway, so we're basically defining our custom element in this template, where we just have the template's inner HTML is an H1 with a hello and then the slot tag. Then we move over to the actual class. So this is all of the JavaScript code that's needed in order to implement this. We have a constructor, and after the constructor, you always have to call super. And then we're basically attaching our shadow mode, attaching the shadow DOM to this component. And we're just going to add whatever is in the template into the shadow DOM as well. And then the last bit is the custom element define. So we're running this little bit of JavaScript to say to the browser that anytime you see the hello-world tag, I want you to use this hello world class. Now, the fun thing about web components that may bite you in the ass is that they all have to have a dash in the name. So when you're naming your web components, make sure that there is a dash somewhere in there, or else you may be debugging it and going like, why the heck doesn't this work? And in fact, customarily, you use 2 different words or more than 2 words, but you can actually just have the word and a dash, and it'll work. That is weird, but it does work. All right. So what that looks like on a page is something like this, where we have our 2 hello worlds, and we're passing in the spans. And we're actually naming those slots so that the component knows where to insert it into the template that we had on the previous page. So that is a super useful ability of web components. And since they're, you can individually style those things as well. So you could put your class on each of the different hello worlds, give them completely different stylings if you want from the external side of things, or you can go on the internals and style them there as well. Now, I think probably a few in the audience are probably saying, hey, aren't you contradicting yourself? Web components still need JavaScript, right? Yeah, I was kind of hoping you wouldn't notice, but you're all smart people. I'm sure that you did. So this is where I will pitch an open source project that I actually work on. It's called Enhance. Enhance is an open source HTML first framework. And basically what it is it allows you to wow, that was, okay, you know what? That's a new word. We're gonna put that in the vernacular, web and leverage together. Okay, yeah, I'm gonna get that into the Urban Dictionary or something. Anyway, it allows you to leverage web standards. So what we've done with Enhance is you write your web components just like you would for any client-side application, where you would be doing the client-side rendering, Anyway, the main difference is that Enhance will expand your web components on the server side. So any of the HTML that lands in the browser is already expanded. So it shows up in the light DOM, so immediately what happens when that first page loads, before any JavaScript gets loaded, your web components are already working because you've written them in a progressive enhanced type of way. And then when the JavaScript for your web component lands later, then you can add additional things to it to make it more interactive, or you can replace the entire web component itself with a shadow DOM compatible version. So it's a pretty handy open source project. So part of the things that it does, when it's server-side rendering, it'll go through all of your web components, extract the shadow DOM portions, and put them into light DOM when it sends the initial HTML down. Also, any of the styling that is inside the web component as well, it will hoist that to the head of the web page that is sending back, so that all of the styles are applied as well. And then you may find at that point, you don't even really need to add any JavaScript because your page is already working, your app is working. But if you do add JavaScript, then you will get the additional functionality. You will have the ability to replace that component with the Shadow DOM version as well, or the JS client-side rendered. Anyway, the second lesson in rendering off the main thread is just reuse what the browser already gives you. I used React for 7 years. React's great. It was definitely the right choice, for many, many years. But the platform has gotten really, really good over the last 5 years. And a lot of the things that React provides to you, or Vue provides to you, or Angular provides to you, have platform capabilities now that you may not need to reach for those giant JavaScript frameworks anymore. So one of the fun things I like to say is that even though I have 7 years of React experience, I use it for many projects, I would say that it's more like I have 1 year of React experience like 5 different times. Does anybody else notice that? I mean, when I started using React, it was React Create Element, and then it was JSX, and then it was class components, and then it was functional components, and then it was hooks. So the thing that I got kind of tired of was that every 12 to 18 months, I was really just kind of rewriting my application, wasn't providing any benefit to the users. It was just, I was chasing the fashion there. And by eschewing some of these large frameworks, you can just stick with the platform, and whatever you build that's on top of the platform, it's going to work 20 years from now. So any investment that you put into web components are not going away. They're in the browser. The browser never takes anything out, so you're not wasting your time chasing the latest JavaScript trends. Anyway, that's not to say that if you use React, you're doing it wrong, because I don't know the constraints that you operate under. I don't know what that's getting freaky, isn't it? So anyway, it's not a bad decision to use React. It's just, maybe take a look at the platform. It's pretty cool. All right. I'm not sure if in Norway you have the reduce, reuse, recycle, or is that more of a North American thing? Anyway, this is where that whole kind of thing goes right off the rails, because we're not going to recycle things. In this metaphor, it breaks down, so I'm going to rename it to offload. And you're probably thinking, finally, this guy's actually going to talk about the thing I came in here to learn about, which is rendering things off the main thread. And yes, you're right, it is finally time for that. All right, so In order to render things off the main thread, we're going to take advantage of web workers. So they're this wonderful browser feature which allows you to spin up a separate background thread to do like any kind of computationally intensive actions off the main thread. So they don't offer you every browser API, but they do offer you a good subset of them. Most importantly, you can do fetch for network requests, which thank God, because without that, it would be pretty useless. But you can also use the Web Crypto API, IndexedDB, which is a great way to share data between the main thread and the web workers. Plus functions like set timeout and set interval allow you to basically set up the web worker to run things in the background at various intervals, so you can schedule some jobs. However, the web worker can't directly manipulate the DOM. So that's not uncommon. Anybody who's done any iOS or Android programming will probably know that it's exactly the same thing there as well. In fact, in both of those operating systems, the main thread is called the UI thread because that's where all of the UI stuff is happening. And any communication between the main thread and the web worker is done through this method called post message. And let's take a look at an example of what that would look like. So a quick example of using post message. I feel like we should be playing some techno music right now, but hey, let's see what we can do. All right, so our user clicks on a button to save a new to-do item in our fictional to-do app. I'm so sorry, I don't know what to do about this. We're just gonna have to power through. Anyway, so yes, it clicks on a button to create a new to-do. And that's going to fire off this post message where we're going to send the data over to our web worker. Then our web worker has a method in there called onMessage. And so on the onMessage event, it sends the new to-do to our backend server. So it's communicating with the server for us. And then once it receives a response back from the server, it will post a message back to the main thread. And in the main thread, we have another onMessage handler, which is able to update our store. So one of the patterns that we end up using is putting a store in order to hold all of the data for the page itself. And then once the store gets all that data, it's going to fire off an event to tell any of the web components that are listening to it that they should update themselves. So that's pretty handy. So some code on this for our to-do application. So our user has clicked on a button that calls our save to-do function. So first thing that we do is check to see if the worker already exists. If the worker doesn't exist, we're going to create it at that point in time. And then we're just going to post a message, and the data is just the to-do item that we've just added. And so that goes over to our worker. Now, over on the web worker side of things, the new message is received. And this is our onMessage function here. And once it is received, we're just going to send it to the backend server that we have using this fetch API. And after that, it'll wait for the response, convert it over to JSON, and then once that's done, we'll just post that result back to the UI. So that is pretty handy because the UI will have to know what the ID of the to-do is in order to update it for being able to do things like edit and delete later. So web worker is sending the information back to our main application. In the to-do API, we have our store, and that has this function called mutate. So anytime a new to-do item comes in, we make a copy of our current items, our current to-do items. We add the new one to it, and we just set that back into the store. So hey, that wasn't too bad at all. It's in the actual store API where things get a lot more fun. All right, so our store has to have a way to communicate with the rest of the web components. And we really have two functions for that. And the first is subscribe. So anytime a web component wants to listen to events from the store, it calls the subscribe function, and it basically tells it what props it wants to listen to. And then, of course, when a web component is getting removed from the page, we want to be able to clean things up as well, so we have an unsubscribe, and we just basically take that listener out. Now, when any kind of change to the store is actually happening, we just have this notify function, which is going to go through all of our listeners and notify all those different web components that something has changed. And finally, when we actually create the store object handler itself, we're going to be using a proxy in order to be able to listen to any of these changes. So basically, the proxy is going to update anytime you call store dot to-dos or store dot whatever, and we change that value using the proxy function, the proxy object, it will know that it has to send out the notify event to all of the web components itself. And then finally, we just create the store itself using the proxy object. All right. In our to-do list web component, we have our constructor. Again, we call super, and the two things that we do is basically we grab our API in order to be able to make those calls to the web worker, and we're going to set update as well. In the connected callback, so one of the interesting things about web components is the constructor is called once and only once when the first time the class is used on the page. But anytime you add a web component, so we had that hello world example where we had multiple hello worlds, so the connected callback would be called for each individual hello world element. So this way, if you were using this to-do component multiple times, it would subscribe to the store's notify function twice. All right, so we have our connected callback, and we're passing in the props that we want to listen to. And in this case, we just want the to-dos. So our store could have many, many, many properties in it, but we don't want to be notified and update our component on every change. We only want to have it update on the things that we care about. And in this case, it's to-dos. And as I said, when the component gets removed from the page, we want to clean up things. So we have our disconnected callback, and that's where we're going to unsubscribe from the API. We're going to remove that listener. And then finally, when something happens, we get this update. What we're just doing here is we're going through all of our to-dos. We're seeing what has actually changed, and then we're going to update our DOM as well. Now, if I can possibly not send people into a seizure if I change this. No guarantees. Wow. No, I don't want to draw blue dots on the screen. Thank you for that new functionality, slides.com, that I never asked for. All right. So, really, really dumb. I'm so sorry. Okay. Really kind of dumb example. Pro tip. Work with the designer. They're absolutely great. I am not a UI designer. I am more of a back-end person myself. Pro tip, marry a designer. They come slightly cheaper, but I can't guarantee that. All right, so if I type in first to do, and probably what the other nice thing we should do is inspect this. And I swung right by the network. All right. I'm going to try to make this a little larger for folks. Yeah, that's not disconcerting at all. Again, I apologize. All right, so we did our first to-do, and we didn't have the network channel. So let's do our second. Did I just type first again? Yeah, okay. I am a really super fast typer. Unfortunately, 1/3 of every keystroke I hit is the backspace key, so I don't know if that counts really. Yeah, so if you can get through the flickering here, you can see in the inspector that we had this call to to-dos, and there's a little socket, or not a socket, it's almost like a sprocket widget. Anyway, that's basically specifying that it's not happening on the main thread, it's happening in a web worker. Whoa, okay, maybe I should stop doing this. Is anybody else having seizures? All right, let's do that. Hopefully, yeah, okay. I need to make that a little, just so I can actually see that. Again, see, not a designer, didn't actually do the screen size stuff correctly. Work with an absolutely fantastic person who does this stuff usually for me. Yeesh, anyway, let's just delete one of these to-dos, if I can. Yeah, all right. Wow. Okay, again, you can see the widget next to the delete command. So all that stuff is happening in the web worker itself. So our everything is getting handled there. That is getting really frustrating. Yeah. Apparently it doesn't like white, but that's cool. While we're messing with stuff, I'm going to go over here once again, and I'm just going to turn off JavaScript. And so now there is no JavaScript on this page whatsoever. Well, it's actually reloaded the page. It's blocking all the kind of JavaScript, but I can actually do a so I'm going to add in a third to do. I even misspelled it, so I'm really good like that. And if we look down at our network, did it? Is Java? Oh no, for some reason I didn't actually hit the JavaScript off button. Maybe it's because the screen's bouncing around. Okay, now JavaScript's off. Let's clear our network panel. And this time, what actually happened there is we added a fourth to-do, and you can see that a lot more things, well, maybe you could see a lot more things. Basically, since JavaScript's off, we're not communicating with the web worker, so we're falling back to just using plain old forms in HTML, and we're making a post back to our server in order to be able to store the to-do. Then it is sending back the data for us in order to re-render the page. So at least in this way, we can actually provide the functionality with or without JavaScript. So it's a lot nicer when there is JavaScript because the entire page doesn't reload, but if for some reason something goes wrong, things still work. I feel like it's almost like if I scroll the mouse, it really kind of messes with things. Cool. Well, it just switched to mirroring, so that's neat. You know what? I could try. I don't think it's Firefox. We had this issue with a Windows computer as well earlier. All right. I don't even, there we go. Let's go back over here. All right, so basically, sorry, this went off the rails. Our third lesson in rendering off the main thread is to use web workers anytime you have kind of expensive operations. But only do that after you've reduced the amount of JavaScript you use and taking advantage of the platform, because then you're buying into a whole other way of doing things and you might not even need it. All right, so in conclusion, reduce the amount of JavaScript that's required in order to build your HTML. I'm not actually sure why we decided that we should be building HTML on the client using JavaScript to do it. It doesn't seem like that's what browsers are really for, but you know, we went down that path for a number of years, myself included. Reuse what the platform already provides you. The platform has gotten incredibly good over the past 5 years. There's a lot of things that were introduced, and I'm absolutely amazed with some of the stuff that CSS is able to do. So if you're not a CSS expert like myself, again, hire somebody that's really great at that. Because there's a lot of things you can do in CSS that you can just wipe out a lot of JavaScript that you're probably using already. And in fact, somebody was asking me the other day because I was showing them an example and they were like, wow, that's an amazing date combo box. How did you do that? And it's like, it's accessible and everything. What have you done? What framework are you using? Like, what NPM package do you install for that? And I was like, oh, input type date. And yeah, they were kind of blown away that that was actually something that was in the platform because they weren't paying attention for a while. And then, of course, the last bit is offload kind of those expensive, time-consuming tasks to web workers, whether it's like computation things like like mining for Bitcoin in your users' browsers, or if it's communicating with your backend server, or if it's other tasks like that, you can offload them to web workers and make your life a lot easier. All right, so in conclusion, use JavaScript. Not a lot. Mostly for progressive enhancement. And I have to give a hat tip to Michael Pollan from, I think that's where I stole that particular turn of phrase from. Obviously his was, eat food, not a lot, mostly fruits and vegetables. I think is what his original one was. Anyway, if you want to get more information about that open source project that I was talking about, which I've used for the example, it's called Enhance. This is the best way to get in touch with us. All the information is there, and I think we still have a few minutes if there's any questions from folks. Yeah. I'm going to apologize. My hearing is shot to hell because I'm almost 50, so could you speak up for me? Yeah, I haven't actually used Blazor myself. We are using WebAssembly and some of the things that we do on the server side in order to speed up the rendering of things. One of the things that we typically use WebAssembly for is doing image manipulation. So we will upload an image to our S3 bucket, and we don't care what the size of it is. We'll just upload a very large image, and then depending upon the thing that's requested from the client, we'll automatically resize that image and like cache it in our S3 bucket. So for the next person that comes along, it's a lot faster. And we're using WebAssembly on the server in order to do that, and it's absolutely fantastic. So any of the things that are slower that could be done on the server in JavaScript, we look to move them to WebAssembly as well. So. Yeah.
So when you turn off the JavaScript, is it the same loading time?
The same loading time?
Or is it like slightly different?
Yeah, so it would be slightly faster because you're not even loading the JavaScript at that point in time. But basically, to get to that baseline where the HTML is working and you can still operate, it would be exactly the same because you would load the HTML and then no JavaScript comes down, or you would load the HTML, be able to work with it, and then the JavaScript comes down, which makes it, enhances it, makes it better. But there's no real difference in time to first interaction, whether you have JavaScript on or off in this case. Okay, well, there's no other questions. Feel free to hit me up at any point in time in the conference if you are too shy to ask a question in a large group, like I would be. So, yeah. Thank you all for coming out. I hope you got some use out of this talk. Oh, cool. Thanks so much.